Hi guys, today we're going to talk about prisms and surface area and volume of prisms. So a few things that we need to make sure we know are just some vocabulary. I'm pretty sure there's some vocabulary questions in your homework. So prism is a polyhedron with exactly two congruent parallel faces. Those are called the bases. The bases are the parallel faces, and the shape of the base kind of defines what type of prism you're looking at, a rectangular prism, or a triangular prism, or a hexagonal prism. What you're looking at right here is a pentagonal base prism. So I'd call it a pentagonal prism. The lateral faces are the faces that intersect the bases. And they intersect the bases. A lot of times, if it's a right prism, they're perpendicular. We're going to talk about that in a minute. An altitude is the segment that joins the bases, and the height is the length of the altitude, right? Okay. And a lateral edge would be an altitude would look a lot like a lateral edge. It's kind of if you were physically touching a lateral edge, that would be represented by an altitude or lateral face. So a couple of different prisms that we'll talk about are right prism and oblique prism. We won't do a lot with an oblique prism, but a little bit of right prism. In a right prism, the lateral faces are rectangles and the lateral edge is an altitude. So in this case, I'd be talking about here's a lateral edge right here, and the lateral faces are the rectangles here, here, and in the back. So think about putting a good idea to sometimes put a tissue box in front of you, and then the top and the bottom might be the bases, and then all around the sides would be the lateral faces. And in an oblique prism, one or more of the lateral faces are not rectangles. In this case, they look like parallelograms. Maybe you would have one that's a triangular face. They can be different shapes. So moving on. Let's talk about how you're going to find the lateral area. The lateral area is the sum of the areas of the lateral faces. And if you are accustomed to being able to take apart something like a cardboard box and drawing what we would call like a net, then you can find the lateral area or the surface area just by taking it apart a little bit. But the lateral area is a lot more useful when we talk about cylinders than with prisms so much. A lot of times with prisms, we don't use it quite as much. But the lateral area is the perimeter of the perimeter of the base shape. Remember that we're talking about the base shape, whether that's a rectangle or a triangle or a hexagon or something else. And the height is the height of the prism. That's kind of an important part as well. Okay, and then the total surface area, sometimes people call it total area, sometimes people just call it surface area, would be the sum of the areas of all of the faces of your prism. So if you would add the lateral area plus two bases, remember that you have two bases in a prism. The two bases are the parallel faces. So this capital B right here stands for the area of the base shape. Remember, you're concerned about the fact that that might be a rectangle, maybe a triangle, maybe a hexagon or a pentagon. I'll write those three because there's typically those that we're going to use a lot. And lateral area is still perimeter of the base shape times the height of the prism, right? So that didn't change, plus 2 times the area of the base shape will give you the total surface area. You can just call it surface area. You can call it total area. I've seen it both ways. The volume of a prism is equal to the area of the base shape times the height of the prism. So oftentimes we just represent capital B for the area of the base shape and then H for the height of the prism. So just don't mistake that H for the height of the prism with the H in a height when you're finding the actual area. So just make sure you're conscious of that. And then a couple other things for a rectangular prism. For a rectangular prism, I think most of you have probably seen this one before when you're a lot younger. You really just learned that for a rectangular prism, the volume is just equal to the length times the width times the height. It's three-dimensional kind of boxy shape that you're looking at. Length times width times height is the most common thing that you're used to for a rectangular prism. And for a cube, when all of the edges are the same, then the volume is just equal to edge cubed, or you might see it as side cubed. It can be represented either way. You just have to be careful with the E. It's okay to use it in this course, but in another level course, it really would not mean the same thing, okay? So sometimes it might be better to talk about it as a side cubed. All right, so let's talk about finding the surface area and volume of the prism that you see right here. It's really important for you to identify, like, what's your base shape here? So when I'm looking at this particular diagram, I would consider the base shape to be this rectangle down here. Remember, it doesn't really look, if you're looking at the flatness of it, it doesn't look like a rectangle, but we're trying to draw a perspective in 3D, and so we have to try to include that a little bit, the dimension that we're trying to show. All right, so let's talk about finding that surface area, and surface area is equal to lateral area plus 2 times the area of the base shape. So over here, I'm going to find the area of the base shape, and that's going to be, remember, base times height for a rectangle, which is 4 times 3, so that's 12. And I'm just going to put that over there because we're going to need that. But you got to remember, what did we use? If we're doing lateral area, which is perimeter of the base shape, times height of the prism, so if we can move this over just a little bit, perimeter of the base shape times the height of the prism plus 2 times the area of the base. But remember, we already found that over here, so I'm going to put a 12 right there because we found that. Be really careful when you're finding the perimeter of the base shape, whatever base you chose, that's what you need to use to find that perimeter. So be careful. I used 4 and 3 as my base shape in this particular rectangular prism, so I'm going to have to say 4 plus 3 plus 4 plus 3. If you prefer to use 2L plus 2B, that's fine. 5 over here is the height of the prism, so I'm going to put a 5 right there for the height of the prism. Plus, and we know this is now 24. All right, and this is going to be 14 times 5 plus 24, and we're going to get 70 plus 24, which is 94 centimeters squared. Remember that area is still measured in centimeters squared, right? Whether it's total surface area or whichever. So for volume, we're just going to take the easy way out, something you're already familiar with, length times width times height. That's 4 times 3 times 5. And then we're going to get 60 centimeters cubed that way. And that's our volume, the easiest way that we can find it. The rectangular prism is probably the easiest one to do, but there are different ways. If you prefer to find the surface area by just thinking about how many rectangles you're looking at, remember that when you're looking at the number of rectangles, you're really going to have to consider the fact that you have a top and bottom, which would be considered here. Let's see. The top and bottom of the box would have dimensions 4 by 3, and you have 2 of those. So if you want to find the area of one, that's 12, but then you have to double it. The sides would have dimensions 5 by 3, if you want to look at it that way. You have 2 of those, so that would be 15 times 2. And then the front and the back of the box would have dimensions 5 by 4, so you'd have to multiply 5 times 4 and get 20, and then double that because you have a front and back of the box. That's just another way to find surface area if that's easier for you. Let's take a look at another example. Now we're going to find the surface area and volume of a triangular prism. And again, I want you to be careful that you make sure you identify, like, what is that base shape, right? Obviously, it's a triangular prism, so the base shape is a triangle. And we're going to keep that in mind. So step one, the first thing we're going to do is we're going to find the area of the base shape. We're going to find the area of the base. And how do we do that? We do base times height divided by 2. Let's take a look at one of those triangles, right? One of those triangles is right here. And if we shade that, either one, that shouldn't make any difference. How do we find area? Remember, the base and the height have to be perpendicular to each other. So you can just say 3 times 4 divided by 2. So the area of the base shape is going to be 6, right? Great. Now let's figure out what the surface area is. So for surface area, we're going to do lateral area plus 2 times the base, because we have 2 bases, top and bottom. So that's perimeter of the base shape times the height of the prism plus 2 times, we already figured out what the area of the base shape was. That was 6, remember? All right, now let's talk about that perimeter. The perimeter of the base shape would be 3 plus 4 plus, what's missing is the side of the triangle in the front. But if you know your Pythagorean theorem or you know your Pythagorean triples, then you know that that's 5. and that'll tell you what that is. And then this first H for perimeter times height of the prism. The height of the prism is what? That's 6, right? Remember that that's 6, and then plus 12. So then we're going to get 12 times 6 plus 12, which should give you 72 centimeters squared for the surface area. Now let's talk about volume. So for volume, remember we're doing the area of the base shape times the height of the prism, right? That capital B is area of the base shape, right? And what was our base shape? Our base shape was a triangle, and then this is height of the prism. So the area of the base shape, we already found it before, and we had 6. I don't know if you remember, but it was in blue at the top. That was 6. And the height of our prism was also 6. So our volume for our triangular prism is 36 centimeters cubed, cubic centimeters. Remember, cubic centimeters for our volume is measured in 3 dimensions. So we're multiplying centimeters times another centimeters. Last one is generally right here about this as most challenging as it's going to get. We're going to find the surface area and volume of this hexagonal prism that we see right here. We're going to find the surface area and volume. And in order to find the surface area and volume, again, I want you to keep in mind that the very first thing we want to do is we want to find at capital B the area of the base shape, right? And that happens to be a regular hexagon. So I'm going to draw a regular hexagon, and we're going to put some information in there a little bit. You remember how to find the length of the apothem, so that if we're doing this area, we're going to say apothem times perimeter divided by 2, right? And you were told that this side length was 6. Which means this must be 3, and this is 3 square root of 3 because 30 degrees is up here, 60 degrees is down here, right? So the apothem is 3 square root of 3. The perimeter is going to be 6 times 6 sides, which is 36, all divided by 2. When you simplify all that, you should get 54 square root of 3. Remember that this is our capital B, our area of the base shape, right? That's important when we're finding surface area and volume. Okay. So now let's talk about the surface area. So for the surface area, this is the next thing we're going to do. That would be the lateral area plus 2 times the area of the base. Remember that that means perimeter of the base shape times the height of the prism plus 2 times area of the base. And we know what that is already. So for the perimeter of the base shape, we know that each edge of the base shape, each edge of that hexagonal base is 6. And then times, how many sides have we got? We've got 6 sides, right? So we're going to need 6. And then times height of the prism. The height of the prism is known to be 12. The height should connect the 2 congruent parallel bases, right? That's what that should do. Plus 2 times, and then the area of the base shape we already found was 54 square root of 3. So now we get 36 times 12 plus 108 square root of 3, and we get 432 plus 108 square root of 3, and that will all be in meters squared because that was surface area, right? Okay, so let's now talk about volume. Volume, we're going to do this one in a different color, is equal to area of the base shape times height of the prism. Remember that we already found the area of the base shape. That was 54 square root of 3. We did that at the very beginning. It's a good idea to do that. And the height of the prism was known to be 12. And when we multiply 54 times 12, we will get 648 square root of 3 meters cubed, and that's the volume of your hexagonal prism. Of course, if you have to round an answer, then you would round your answer at the very end, and that's it. We're done.